Okay, so I assume that everyone can hear me well. So let's start a basic introduction to data science. So we all are here to discuss some of the introductory concepts to the data science. What is data science? What a data scientist uh, does, and what are his or her responsibilities, different applications in real life, and what could be the roadmap to become a data scientist, and what are the expectations uh, of companies from a data scientist when they hire you, and finally how to master all of these quickly, some of the fundamental steps. So let's start with the very first slide, which is all about data science introduction. And basically it starts with data. So what is data? So I'm gonna discuss um, what is data science and how data scientists work, what are their responsibilities, and why it is important for the companies and the businesses to grow with the help of data science, and especially when the technology is booming and growing. So a lot of applications we have in real life. So let's start it with the what is data science. So data science is all about the data, identifying some useful patterns and information from a data. So there is a very fundamental question which I need to ask here at this point. That is, what is the difference between data and information? So something which is of interest to a user is information, and rest is data. So data is everywhere. So I can give you an example for that. Suppose you have written something on a piece of paper, like my name is X. So this is an information for the person named X, and for rest of you, it is just the data. So that is the basic difference between data and information. So what data science is all about, it starts with solving a business problem, which is basically uh, analyzing the data, large amount of data. Basically, it's just not the small amount, it's basically the large amount of the data. Why I'm saying that? Because uh, as the technology grows, every product, every thing become smart these days. For example, smart homes, smart cities, smart products. So every product, every tool we are using these days around us is smart in nature. So every smart thing, every smart product generates a lot of data. So we need to identify and we need to deal with that large amount of data to solve a particular business problem. Basically, business problem is nothing but some key questions that needs to be answered in order to help the business or help the company grows and to earn and make profits out of it. So what I can say is here at this point, the hidden patterns and insights is very useful for any business. So a data scientist basically analyze those huge data with the help of some tools and techniques, basically some advanced tools, and some of the libraries which we will discuss later on, and construct a knowledge base out of it. And finally, the last step for that is to design a machine learning model to make an informed decision, which is like getting ahead of the competition to help the business grow. So let's start with what is data, what are the responsibilities of a data scientist. As I already told you, this is the time of big data. So data is everywhere. So we need to make use of it for own benefit. So what are the responsibilities? First one, a data scientist should be curious and inquisitive and innovative in nature. They should be asking some key questions, some analytical questions, therefore should have some cognitive and good analyzing capabilities. and problem solving skills. Of course, you need to collect a large amount of data using different techniques, which is not in today's webinar scope. So we'll discuss it later on. Then you need to make the visualization very important. It's a very important actually for the end users, because you need to present your results, your analysis, what you have solved, and how you're going to present these results to the end user. So it is all about data visualization, and we are having different tools in the market like Tableau and Power BI for that, but we are not using those tools. So we'll be using some advanced techniques, mathematical and statistical methods for that. We will discuss this later on as well. And then what is that? Answering critical questions. Of course, if you ask critical questions, you need to answer it using your knowledge and skills, your experience, your expertise, and of course, your coding skills are also necessary for that. Then you need to design on the basis of all those skills and expertise. You need to design some machine learning models, basically predictive models. Why I'm saying predictive? Because there should be involved in a prediction if you want to solve a problem. So basically in data science, we mostly deal with the classification problem and regression problems. So it's all about prediction. Either you're predicting a quantitative value or qualitative value. It's all about predictive ML models, and which helps in decision making. And who are the decision makers? It's the company or the business of which data you are processing or working on. Moving ahead, so to the next, what is the complete roadmap and what are the essential skills a data scientist would require, or what is that key concepts you need to have to become a data scientist, a successful data scientist? First one, you need to have a good understanding of statistics and probability. Statistics means analyzing the population, like different sampling techniques you need to learn about. You need to learn how to calculate different central tendency measures like mean, median, mode, and you need to do some significance test out of it. Like, for example, if I say like a pharmaceutical company manufactured a new drug and they want to analyze the effectiveness of that drug, so how they're gonna do that? So it's all about statistics, which comes into play. They can perform some statistical significance test like Welch t-test out of it to test its effectiveness on a specific sample of a large population. And then we have another essential skill, that is the probability. You need to have understanding and good knowledge of probability distributions. Like basically, we mostly use normal distribution, or we can say Gaussian distribution, and other distributions like Poisson distribution. So we need to have good understanding of different probability distribution, how to identify and estimate the parameters of those distribution, and what kind of distribution a data set. So suppose you are given a particular data set, and then you need to know what distribution this data comes from. So you need to identify which distribution fits well to this data. So that's all about probability, which comes into play at that point of time. Then mathematics is there. So mathematics is mostly about, so we're gonna use linear algebra, and some of the geometry part we'll be discussing throughout the course. And optimization thing. Optimization, of course, if you're using machine learning, so you need to have an optimization. Optimization is nothing but fitting a machine learning model mathematically. If I can say, it just like minimizing some mathematical cost function or return function that should be maximized, or if it's an error function that should be minimized. So depending on the nature of the problem, you have to deal about that. Then very important, I can say, is web scraping in SQL. Because you are dealing with large amount of data, you need to address a lot of, you need to write a lot of queries, simple queries, complex queries, different types of tables you need to join. So you need to have knowledge, good understanding of joins and different aspects of sequential query, structured query language, SQL. And web scraping is another thing when where you can use different Python libraries to get the data out of a website directly using Beautiful Soup is one package you can use to scrape any website or web page. Then you need to have understanding of Python language fundamentals like basic structured loops, variables, statements, expression, everything basics. You should have good knowledge and good hands-on skills with that. And then we have data exploration libraries like NumPy and Pandas. NumPy is basically for numerical computation, basically when you deal with arrays. So anything, because Python, traditional Python have list, it uses list for everything, but lists are actually quite slow in execution. So this NumPy converts all those lists into arrays, and arrays execution are faster because of their contiguous nature. And then Pandas is another library for data handling, like loading a huge amount of data in the forms of data frames and series. There are two types of data available in Pandas. One is one-dimensional and another is n-dimensional. Then we need to understand another essential skill is, as I told before as well, that is data visualization. You should be able to go through this step. You should understand how you can visualize the data. So in real life, you'll be given a data set, and then you will be asked that you should understand, or you need to go through the data and completely see what is inside it. Because without visualization, you cannot analyze it. So you should be having good knowledge, good hands-on with Matplotlib and Seaborn. These are two Python libraries which we'll be using throughout the course in our practical sessions. How you can plot graphs, how you can construct tables out of randomly unstructured data, and like different types of other graphs like bar chart, histograms, and other things. So we'll be exploring this in detail later on. Then very important is machine learning. So machine learning is basically are of two types, supervised and unsupervised. So there's also a third type of machine learning, which is reinforcement learning, but that's not in the scope of this webinar. So we'll be talking about, and we'll be doing those machine learning, and we'll be exploring and using different machine learning algorithms throughout the course. Then, of course, you need to have a domain-specific knowledge. It is as important as all these above mentioned skills here. What I mean by the domain-specific knowledge is, if you're solving a healthcare problem, you should be having some basic understanding how the data flows through hospital, or how a patient gets treated starting from the diagnosis part, how the data generates. So it's all about, you should have some specific domain-specific knowledge beforehand you start analyzing the problem or analyzing the data. So machine learning, as I told you, it's nothing but finding patterns from the data. That's the goal of data science over here. So in mathematically, or I can say mathematically, we can define machine learning as fitting a function. It could be linear function, or it could be a non-linear function in nature to a data set. So that's where the predictive modeling comes into play. You need to generalize a mathematical function from the data for an unseen data, or you can say from another type of data, or you can say we have training data and test data. So that's the so we'll not be discussing the details of machine learning. What are the training data and what are the test data? So basically, machine learning gets trained on the training data, and to evaluate the trained model, we use test data. So that is kind of unseen data to the model, and we will be able to see that how well it has generalized for that unseen data for real world data. So machine learning's goal and the data science goal is nothing but the same. They goes hand in hand. So without machine learning, you cannot be a data scientist. You need to have a good understanding of all the algorithms, all the mathematics behind and statistics behind machine learning, and for which I'll also recommend some books in the last slide of this presentation. So we'll be using, as I told before, supervised machine learning. So supervised machine learning is all about uh, input and output pairs. So we have a data set which contains input and output as well. So basically, we supervise an algorithm in this machine learning paradigm to fit a mathematical function based on the provided input and a corresponding output. So that mathematical fit would then be used for an unseen input. It means that will be, after it gets trained on a trained data, then we'll be testing it on our test data, just giving the input, and then we'll see what is the actual output it predicts and what is the expected output, and that expected minus actual will gives the error. So that error needs to be minimized for a successful model, and it is very important for a data scientist to understand this from mathematical point of view, how to minimize that error, and that's where the optimization comes into play. So we gonna have different optimization algorithms for that, and data scientist needs to have good and really good understanding of how to fit optimize an algorithm over a large data set. That's what the science of the data here. Then we have unsupervised learning. So basically, we do not have output pairs here. We just have inputs, and we classify those inputs, those training data set on the basis of some similarity. So one similarity metric would be, for example, Euclidean distance between 2 points. The more the similar they are, they will be classified into the same cluster. So, for example, many of you know that KNN classifier, that is a K nearest neighbor clustering algorithm, which classify a random point on the basis of the similarity index measure, which I said it here, Euclidean distance or any other you can use. There are many of them. And then it assigns the cluster on the basis of that distance value, right? So we have other algorithms as well in this machine learning paradigm. Then we have reinforcement learning. It is also one of the most challenging, or you can say very hot machine learning area these days for research. And my own research is actually in reinforcement learning. So it doesn't require any training data, and it learns from the direct interaction. So it is a bit different from what we have seen through supervised and unsupervised learning. So it's a whole new area, and it is also used in solving data science a lot of problems. We'll discuss it later on. So this is all about the machine learning part, which you need to have to become a data scientist. That is the complete roadmap. And let's look about the data which we were talking about in previous slide. So there are two types of data we can say we'll be dealing throughout the data science projects or problem which you're going to be solving in the future, or making solving real projects in companies and different venues, right? So first one is quantitative data and another one is qualitative data. So I think you already have some basic understanding of what is quantitative and what is qualitative data. Quantitative data is basically just, as you can see, it starts with the word quantity. So it is all about numbers, right? And qualitative means it's all about classes and the categories or characteristics, you can say. So very basic example, a person's age, uh, you can say, is quantitative and gender is qualitative, or a person's weight is quantitative in nature. Uh, and we can also have qualitative, a lot of qualitative data we'll be discussing afterwards. So in quantitative we have another type of two further types of data. One is discrete and one is continuous. So discrete data, where we'll be having discrete values, uh, like a person's age is a discrete value, or and continuous, like a person's weight. Similarly, in qualitative, we have ordinal and nominal, these two further data types. Ordinal, simple classes like black and white, and in ordinal, we're going to have some kind of ordering involved with ordinal data classes like good, bad, better, worse, like this. Then we have structured data. So structured data is like the data which has some sort of structures which can be organized in the form of tables. So of course, structured, unstructured, and semi-structured, they all three fall in this two broad classes, quantitative and qualitative. Structured data could be quantitative or qualitative. So tables, Excel sheets, these are just examples of structured data. And in unstructured data, we can say like images, audios, and logs. Logs means like when we access websites. So when we request a web page or we click a button, it goes to a server and server generates some logs. So these kind of logs. So there is a huge amount of logs generated by a single user per minute. So I'm not sure about how many, but it's like lots of petabytes of data are being generated every minute on internet. So there's a huge pile of unstructured data available. So in fact, most of the data around us is 80% unstructured in nature. And another type of data is semi-structured data, which is like emails and zipped file, where we have some sort of structure available, like XML or XML files, where we have some sort of structures available in data. So it's like semi-structured. That's why it has some structure and some non-structured. So it's a mixture of structured and unstructured. Then we have, these are actually the fundamental steps, fundamental steps. What I can say is like every problem of data science needs to go through these steps. First one is the business problem. So of course we need to solve a business problem. So we need to have some requirements handy at hand, like a company handing over a 5-year sales record. Then they want their data scientists to work on this problem, that why the sales of a company is going down. What is the problem? So we need to identify the problem from analyzing that huge 5-year sales data. So there is a business problem always that should be solved by a data scientist or data analyst. So without a problem, there is no solution. So it starts always with a problem, and then you collect, either you have been provided the data, or you need to collect the data through various techniques, which we will discuss later on in detail. There are a lot of techniques for that. Then after collection and storage, of course, you need to store the data in somewhere, like some point, like in databases, data lakes, or data warehouse. There are a lot of technologies to do that. For big data, we have Hadoop distributed file system for that, and other techniques as well. And then after that, we clean the data for to perform the SQL queries or different analysis operation. It has to be cleaned and pre-processed. Like you need to remove null values and inconsistent formatting and different types of issues, formatting issues, and a lot of errors, data types error you need to resolve. So it's the most time-consuming task for a data science problem. Then this is the actual process of data exploration. This is the point where you need to analyze the data. You need to visualize the data using different tools like Matplotlib and Seaborn libraries, or either using some softwares like Tableau and BI at this point, right? And next, there is data modeling. Data modeling is the point where machine learning comes into play. You have the data clean, you have the data available, you have the analysis report. Then you need to solve the problem specified at the first stage. So for that, you need to you need to use mathematics to fit a machine learning algorithm to that data, or to do predictive analytics, or to design and construct a decision-making model. Of course, decision-making to help this business problem to get solved and help the company to improve their sales, which was going down continuously. So at this point, machine learning comes, and you as a data scientist should be having good knowledge or understanding. As I told before, at this point, this is the solution part here. And then after that, when you find the appropriate model, a good fit, mathematically saying a good function that can represent the whole data set well, that can solve this particular problem, or that can predict the solution to this problem, that best model will be tested on some test data set. That is the most model testing. Then we evaluate that model on the test data, and then we deploy it in production, or it could be cloud deployment, or various other local deployment, server deployment. So these are 7 steps here, which needs to be followed by every data scientist to solve any data science problem, no matter the size of the problem, whether big or small. So this is all about the data. And so in this slide, we study what type of data we're going to be dealing about, and what are the fundamental life cycle of the data, how the data flows through a problem, how you understand it, what is each stage, and what you're going to be doing on each stage, and how you will get the final solution, and then you deploy that solution to some cloud platform. And also you need to present that solution to the end users, or the business people, or the company officials for the demonstration. You need that data visualization necessary. You have learned on those essential skills. So they'll be very much required for the final delivery of the solution to that problem you were given at the initial stage. So moving on, we have the expectations, right? So what are the expectations of the companies when you apply for a job? So what companies will be looking for, what they are after, and what skills they would like in you being a data scientist, being handy, and in your expertise list, of course, right? So first one is, as I told before, is the being innovative and critical thinker. The very, very important is you need to think critically, you need to analyze it, you need to think a lot, basically, when you do first look of a data set, a random data set. Could it be structured, unstructured, or semi-structured? You need to analyze it, and you need to identify either you have been given key questions problem by the business as a part of business requirements, or you need to you could be asked in very generic sense that you need to analyze this and help the company growing their business. In that particular point, you need to be a critical thinker. You need to identify what are the challenges and what are the main characteristics and features of variables that I should be analyzing this data that will help that company to grow or expand their business and earn more profit and make more money. So that's at the end of the day, if the company is making money, then they can say that data science is actually paying dividends to them, and who are responsible for the data science and for that dividends to the company is the data scientists. You people will be responsible for that, and you'll be able to solve those critical problems and have the company grow their business. So another skill the companies mostly require, like you should have a good problem solving skills, right? So when you first analyze the data and ask some critical questions that can help the business or the company to grow, you should be having good solution designer and careful analysis you need to do for that in order to solve that problem. So problem understanding and solving is another important aspect which companies look for. And for that, they will test you during their interviews and through different ways, right? So you need to be careful about these first two steps. These are very much required. Then, of course, the third one is good knowledge of any programming language. So basically, most of the data scientists use Python or R, but I would recommend Python because Python is used most of the data scientists in comparison to R, because it has a large set of open source libraries available, ready-made algorithms. You just need to import the package and they're ready to be used. So you need to have good coding skills and programming skills, especially using Python, or if you can prefer R, that would be of no issue. So you can just pick one language, Python or R, whatever suits you well. So go ahead with that. But I would recommend definitely Python if you wanna ask me to pick one. Then you should be having good knowledge, understanding of data extraction techniques, different tools you need to use for extraction or data. Like I told before, web scraping is one way of extracting data from a web page when there is no direct source available. So similarly, there are others. We'll discuss it later on. And then how you should be processing the data. Either you will be using like Microsoft Excel to do the pre-processing of a structured data, or you could be using pandas for that, Python pandas library, another good alternative for that. Then, of course, good communication skills, especially your speaking and writing and expressing yourselves. So you should be good at this because at the end of the day, you will be the person who will be delivering the final solution to the stakeholders, to the major stakeholders, and you will be answering all the difficult questions. You will be telling them the details, and you will be answering more deep technical questions, and finally presenting the visualized results to the business people. So you are the person who starts from a business problem and ends with a solution, right? So throughout that whole cycle of the flow, you need to be very good at this stage, good communication skills is very important, and also you need to be proactive and you should be ahead of the competition. So be prompt, be proactive, and should have some team leadership qualities in you as well. So these are some of the very generic, but these are not limited to every company, so they could be much more than this list. So this is very generic. I have shown here to you people. So you should be making sure that you should have at least these points handy when you are applying for jobs and getting interviewed and all those things, right? So let's move on to our final slide. That is the how you can master, how you can just learn it, and how you can get a job. So first and very foremost thing is you should grasp the foundations of mathematics and statistics, for which I'll be telling you some of the very good books which you should read. You must read, because without solid foundations of these two branches of maths and stat, you couldn't be able to achieve that goal, or that you won't be able to land of your dream job or of your dream company. And second one is like, of course, you need a programming language. So it could be, if you are choosing R, so it will be R language here. Otherwise, I would recommend Python programming. You should be very well versed with Python, all the basics, concept, libraries, everything. You should keep yourself updated with all the latest Python packages, adding to the Python open source libraries. And finally, you need to complete a project. So if you take this course, then you would be studying and practicing all these things in a very comprehensive manner. I can assure you these mathematics and statistics would be very easy once you start taking lectures and tutorials, which I'll be teaching you in the course further on, subsequent lectures and all those things. Of course, we'll be having practical demonstrations. All the libraries will be taking on in a comprehensive manner. Step by step, we will proceed further on. And then we finish a project at the end of this course. And that project you can add to your resume. And that project is something which will give you a job, a good job, or your dream company you can land wherever you want. If you do this project seriously and you learn these things, these 2 steps, if you complete these 3 steps on a serious note, you'll be having a good offer in your hand at the end of this course. So I'll be talking about best books which I personally read. So first one is the Mathematics for Machine Learning. It's not a very lengthy book. It's a very good book for all the mathematics part involved in the machine learning, starting from the linear algebra, and your statistics part. There's another book that is by William Hines. So you can search these books. I have provided the links as well. You can you'll get the recording of this webinar, so you can use these links to get these books downloaded to your device. You can read them as you go or you progresses with the course. I would definitely recommend this Statistics and Probability book by William Hines. Is very detailed and very comprehensive in nature, but it doesn't mean that it's a bit lengthy. It's like 600 pages in this book. It doesn't mean that you have to go from front cover to the back cover. It's not like that. You just need to have basic topics covered. I will give a complete detail of the topic which needs to be covered in probability and statistics. You just read those topics from this book and you will have a solid understanding how these things work at the backstage. Another best book for Python is this one by Wes McKinney. It's for Python for data analysis. It's a very good book. If you want to become a data scientist, you need to have good understanding of Python. I told you before as well. You can also take this best free course for Python from Harvard. So it's your choice, but I would definitely recommend for this book, or you can take this online course and definitely go through this book. I would definitely recommend this book for each one of you who is interested in taking this course. Further on, I will be following these tutorials. Further on, I'll provide another reference list I'll be using to prepare lectures and tutorials, and various assessments we'll be doing. And at the end,